Sorry, I'm eating again. Like, I'm sure this is like crazy for you guys.
You're fine.
You have to remember, it's only 8:30.
I know.
Sorry. I did push my workouts later.
Did you? I go at 6, so I'm home and showered and everything before the kids wake up. So only
I
do it.
I get up at 6, but I do my scripture reading at 6 because then I wake up my kids at 6:30. So there's no way I'm waking up at 5.
Yeah.
No way. So yeah, like my son has piano at 6:45 on Tuesdays.
In the morning?
Yeah.
Oh my goodness.
Yeah, he goes before school because he was doing football after school, and so there's no time to do it after school.
Yeah.
And so he had to go in the morning so he could do it, so he can get it in. So.
Oh my goodness.
Yeah, my other kids go in the after school. So. But yeah, so I had to get up early to get him up Tuesdays, and I do my scripture reading in the morning, and then yeah. So anyways, I don't ever have time to just. My husband's like, maybe you need to get up earlier, and I'm like, no, are you kidding?
I know.
I like sleep too much. There's no way. I'd rather just work out at some point during the day.
See, I always thought that, and then it never happens.
Mm-hmm.
So I'm like, I've got to do the 6 o'clock.
But cleaning the house is a workout, I have to say.
It is.
My heart rate gets up there when I'm cleaning.
Yeah.
So yeah, so I'm always eating when it comes to like having to meet with you guys. Sorry.
That's okay.
And I woke up with a sore throat this morning too, so I'm like,
uh-oh.
I know. My husband looked at me before he left for work. He's like, you're not allowed to get sick. I'm like, I know that. I'm like, I'm trying not to get sick. But I don't know. It's kind of weird. It's a weird time. Like the weather changed, and whenever the weather changes, stuff happens. Like it was 100 degrees last week, and then this week it's in the 70s.
Oh, wow.
So whenever there's a huge drastic change like that, it seems like everyone gets sick. And it brought in, like, there was a huge storm that came in and brought in a bunch of dust and stuff. So I'm enjoying the weather because I know next week it's going to be 100.
Yeah.
But still, like, whenever that drastic change happens within 2 days, because it dropped 30 degrees in 2 days, people always get sick. So, whatever.
Are you originally from Arizona?
For the most part, I've been here since I was 9.
Mm.
So, but before that, I was in Texas, and then I was born in Colorado. So,
Arizona just seems too hot.
Mm-hmm. It does. We have great winters, though. Our winters are your guys' like fall.
See, that would be nice.
Yeah, it gets the hottest it gets in the winter is like 65.
Oh, wow.
And then it gets down to like 30, 32.
Oh, that would be nice.
So yeah, so we have that from probably the end of November through April. That's the kind of weather we have. So.
Oh, that's nice.
Yeah, so that part's nice, but that's why we have a lot of snowbirds down here.
Yeah.
They come. It's funny because I always know they're here when it's October conference. They show up and then they leave right after April conference. So we have like winter visitors in our ward and stuff, and they always, well, after April conference, we'll be heading back. So, yeah, they're here every 6 months. It's fun.
And where are you from, Catherine, originally?
Texas, but I currently am in Mexico.
From Texas?
Mm-hmm.
So,
Should we get started and just have Abigail?
Yeah, we can do that.
Yeah. Let's do that. Should we go over what our answers were? Or did you, I guess we have the answer key, so.
Yeah, I checked them. I didn't have any questions. I kind of.
Like really easy to me.
Yeah, I got mine right, so I didn't have any questions either.
Yeah. I did, like, I was shocked when I took the quiz, the homework quiz. I guessed on like 4 of the questions. I don't remember which ones they were, but I guessed on 4. And my daughter was having a birthday party, and she had like 14 little 13-year-olds over. And I come running out because I gotten 100%. And I came running out. I'm like, yes! And they're all like looking at me like, what? I'm like, I got 100 on my quiz. And they're like, and? I'm like, oh, you guys are mean. I'm like, it was hard. I'm like, I guessed on like 4 of them. I'm like, I kind of thought I knew the answer, but I wasn't sure.
Oh, well, you did better than me then.
Oh, my last quiz I did not do good on.
Oh, and I did text or emailed the teacher about my answer that I got wrong.
Yeah.
And she said that that happened to a couple of others, so she changed it.
Oh, good.
But, yeah, so.
Ugh. What a
Yeah, because
pain.
I had to hurry and do the homework right after I got off last time.
I know, because you opened it.
And I was not ready, and my kids were, like, crazy, and so I was just hurrying and doing it. But.
Yeah, that
So
would be hard.
So should we start on the quiz then?
Yeah, we could do that.
I don't know where, but I guess, has anybody texted her?
I haven't texted her. I don't have my phone near me.
Here, I've got my phone.
I'd hate to start if she's planning on getting on.
I know.
So we can
I'll
try and
text her.
text her and ask her. This is all fun because I'm like relearning this stuff because it's there she is. Hey Abigail.
Oh,
Hey guys, sorry.
hey. You okay?
We're just about to start the quiz, Abigail.
Here goes, like I can't hear you. Okay. Hi there, good morning.
Morning.
Right. Okay, so pulling up the assignment. How'd y'all do on it?
We thought it was easier.
Yeah, it's definitely easier.
And did you get everything right?
Yep.
So we didn't really discuss much because I think we all kind of got it.
It makes me so happy. Yes.
Okay, so should we just go ahead and start with the little group meeting quiz?
Yeah.
Yeah.
Okay, let me move this over so I can see you guys. Okay. So, true. True. That one's easy. Okay. Give all your probability answers as decimals. And not give probability answers as percents. Got it. Okay. Human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. Got it. Use this data to answer the following questions. The blood types and the proportions given in the table above define a probability distribution. That's a good question. What do you guys think?
I want to say it's false, but I was going to pull it like...
It does equal 1, so that is one of the questions. And then, so I'm going to say true.
Okay, hold on. I'm pulling up my little rules of probability.
Here, I've got it here. It says an event is between 0 and 1, which all of them are, and all the outcomes will equal 1, which it does, and the chances of it not occurring is -1, the probability, which is also true.
Nice. Okay. I think it's true too,
Yeah.
based off of those rules.
Yeah, me too.
Okay.
True.
Okay. What is the probability that a randomly selected person in the United States has type O? Round to the nearest 2 decimal places. Okay, type O. Hold on, I have to get a pencil.
I'd say 2.22. Is that what?
What is the probability that a randomly selected person in the United States has type 1? Okay, 4.45. Hold on. Okay, so how did you get your answer? Because I don't know if I did it right. Because I got a different one.
I did 1 over 0.45. What did everybody else do?
I did 0.45 over 4.
What
did you do, Catherine?
Well, I don't know if I'm thinking of this right, but I was just thinking that it's going to just be 0.45.
That's what I was thinking too. Because all these right now are... Huh?
That it would be what?
0.45.
0.45?
Yeah.
Yeah.
Portion of it?
Yeah. Because right now, they're all technically... I mean, they're all decimals right now, but they're all also percentages. And it's just asking... and it says in the description of the population of the United States. So I think that the answer is 0.45.
So to get the probability, the equation is P times X, right?
Yeah.
Yeah.
So
X would be 0.45, right?
Yeah.
Oh, and then P would be 1.
1.
So you would do 1 times 0.45, which would be the 0.45.
Yeah.
Okay.
0.45.
That makes sense.
Yes, I was doing, what was I doing? Hold on. I have to get to my notes. Whoops, wrong page.
Yeah, I was doing the 1 divided by.
Yeah, that's what I was doing.
So.
I was doing the point. Because I was doing, you have 4 groups that they can be, and then I was doing 0.45 because we know that 45% of them are O.
Yeah.
And so I was doing 0.45 over 4.
So, do you guys put the 0 in front of the decimal or no?
I didn't.
I did, but
I just last time, just by adding a comma, it marked it wrong. So I'm like.
And I had emailed her about it, and she gave me the points for it. So even if it is wrong, I mean, we could email it to her.
Yeah.
Okay, I'm just going back. Hold on. I'm going to pull up my, dang it. Oh, I am on that page. Okay, hold on. I'm going to pull up, whoops, not what I wanted. I'm just pulling up the notebook because the next question is kind of,
what is the
probability in the book?
Not have type O.
Okay, so this one is probably one of the first things. It's if you look on number 3, or if you look at the 3 rules, the complement rule.
Yeah, it's 1 minus.
Yeah.
Right?
Yeah.
So
Mm-hmm.
1
So 1
minus
minus 0.45.
0.45
Point
and
five.
then times. And then do you times that by something or just?
No, it's just that.
So it's just 0.55,
Yeah.
Yes, ma'am.
right?
Mm-hmm.
Okay.
Whoops. Too far. Sorry, I'm eating. I'll cover my mic.
I mean,
Okay, so does somebody want to read number 6 or the part of 6?
sure. Caroline Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to the specimen derived from the bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of these samples were from patients who did not have bladder cancer. One of the samples came from a person identified as a bladder cancer patient. Answer the following questions. Number 6. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round to the nearest 3 decimals. So that
1/7, right?
I think it'd be 1/6. Oh wait, oh no, you're right. Okay, sorry. Yeah, I saw 6 of the samples. Okay, 7. Yeah, sorry.
Round to what?
Then 3 decimals. So
143.
1.43?
Yeah, 0.143.
Yeah.
Yep.
But it might help if I put my thing down there, or else I would have gotten that wrong.
Okay, so let's see. Oh, guys, I got new internet. I'm so excited.
Yay!
So I'm not like being cut in and out, and like, I can take the quiz and it doesn't kick me out. Oh my gosh. I'm so excited.
Good.
Thank you. Oh my goodness. Oh, this smells so good. Okay. So, in a combination of a total of 54. Oh, sorry. Did y'all do those?
Yeah.
Go ahead.
Okay, sorry. Excuse me. So, in a combination of a total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. What of the following statement is true? There is little evidence that the dog can detect bladder cancer. This provides strong evidence that dogs can detect bladder cancer.
54 trials.
Yeah, with 54 trials, 22 times. So, let's see, 22 divided by 54 equals, it's only a 50 or a 41% chance, not even half.
Yeah.
So,
What was it saying in the thing about the Christopher
chances of
Columbus drawing that thing?
Let me see here.
I'm going through it. Yeah, so it's only 41%. Okay.
I think that it only shows a little bit of evidence that dogs can detect bladder cancer.
Because it's below 0.5 or?
Yeah, because it's below half. But at the same time, 40% is pretty big compared to like 30% or 20%.
Does it give us a like an exact amount in the reading, like if it was below a certain number or
That's what I'm
above?
looking at. That's what I'm looking
Okay.
at. The one that they are looking at is they're going off of like 2%.
Oh, that's true.
And saying it wasn't a good chance?
Yeah, they're like, there's only a 2% chance that he'll draw the marked chickpea. That is not very likely.
Yeah.
And so then they're saying, and then he does, and they're like, that's like taking, what did they call that? Well, I'm trying to find it. And they're like, that's like him.
The lightning.
Yeah.
Yeah.
The Powerball jackpot. His was a high school student getting into like NFL or something.
Yeah, that's what it was. Like 22 high school students or something getting in, 22% of, I don't know, whatever.
And that's all it says about.
Yeah, I'm looking.
Let's see here. I'm
trying to look and see if there's a general rule of thumb. You know, like if it's under a certain percentage, then it's not very likely. But I don't remember reading anything like that.
Either, and I just read it this morning.
Okay. Looking at the student that does his homework, is this where we need to go through all of the rules and make sure? I don't know. I'm just thinking out loud, sorry. Okay, so the probabilities of all the events add up to, okay, the probability that he does not finish his homework is actually 1 minus the probability that he will finish his homework. That's not really what I'm looking for.
I'm trying to look too if I can see anything.
It does say in the problem, it is very unlikely that a dog would do this well by random chance alone.
That's true. So should we put the percentage is low?
I don't know.
I don't know. I'm kind of... I'm looking at the lottery. Okay, the Powerball thing doesn't really help, so.
I want to say that it provides strong evidence that the dogs can detect bladder cancer because it is a 0.4 chance, and it's saying that it's unlikely that the dog would do this by random chance alone. So then, that makes me think that then he was able to do it without it being random. Like he knows what he's trying to smell for or whatever.
Are you finding p-values?
That's just my thinking.
We already found the p-value. We're trying to figure out if 40% means that it's very likely that provides strong evidence that the dogs can detect cancer or not.
Okay, you know that the p-value, if it's 5% or less,
I personally think 0.4 is high when you're looking at, because normally I would think like it'd be like 0.0, you know what I mean? Like if it was, they wouldn't be able to detect it, I would think it would be under 1% or it'd be like 2%. You know what I mean?
Yeah.
But when you have almost 50%, I think that's pretty good evidence that a lot of dogs can detect it.
you know, it's based on the p-value.
Oh, okay. Hold on, guys.
Statistical significance based on p-value.
Okay. I don't know. Should we come back to that one?
Yeah.
Think about it. What do you guys think?
I mean, I agree with you, Holly, that I think it's strong evidence that shows that they can detect bladder cancer. But
That's what I'm leaning towards, only because
statistically significant.
Okay. Thank you, Mom.
I don't know. Is she asking your mom?
yeah, I think she did.
Right. Okay, so do we decide? It does say that it's very unlikely that dogs would be able to do this by random chance.
But since it says that, and there's such a high percentage, wouldn't that mean that that would be strong evidence that they can't detect it?
I think so.
That's that random anymore. They're like smelling something out.
Mhm.
Yeah, because looking back at the Christopher Columbus one, I just look at like likely and chance is like 0.02 point, like not almost 50%.
Right.
Yeah.
Okay, well, if we can get through the rest of these, and if we see something that changes our mind, we can go back and.
You guys, I'll be right back. I just have to grab my plug for my laptop because
You're
it's
fine.
running out of energy. So I'll be right back.
You're fine. Okay, M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. You reach into a bag of plain M&Ms. What is the probability of drawing a red-colored candy? That would be super yummy. Okay, so 0.13. Are we not doing green? Oh, wait, green is part of it, right? Because they want us to figure out what green is. So that's 1, 2, 3, 4, 5, 6.
Okay, sorry, I'm back. Are we on 8 then?
Yeah.
Yeah.
So
the green would be 0.16.
oh, we're just.
Yeah,
Okay.
did you just add all those and minus it, subtract it from 1? Okay.
0.16 is. Wait, can you
0.14.
tell me that one more time, Catherine?
Just the green number is going to be 0.16 proportion.
0.16.
That's the
Yeah.
number 9.
So that's number 9.
Yeah.
Oh wait, and then what's number 9?
Number 9 is 0.16. We didn't do number 8 yet.
Oh, we didn't. Oh, okay.
No. So wouldn't you just divide 0.13 by 6? To find the probability?
Well, so the probability again is the number or the p-value times x. So x is your.
It'd just be 0.14. No, 0.13, sorry.
0.13, because you do 1 times 0.13, right?
Yeah, it's just that proportion. Because it's about going to be 13 times out of 100 is what that proportion's saying.
So
yeah, 0.13.
Let me just get this right. 8 we have 0.13 and 9 we have 0.16, right? Okay. So that it randomly.
So then it would just be 0.84 for the number 10.
Because you just add up all the others.
Yeah, or you just subtract the green from 1. So you do 1 minus 0.16, which would just be like adding up all the others.
Which is, I got 0.84, is that right?
Yeah.
Okay.
Okay, so is everyone ready for number 11?
Yep.
Yeah.
Okay. The ACT scores of students admitted to a medium-sized public university in the western United States were taken from Capix.com. The following summary statistics were calculated. Use the information from the public university to answer the following questions. Half the observations are less than or equal to what number?
Wouldn't it be 24?
So you're looking at the median. So 24. Yeah, that's what I would say.
Oh, sorry. Half of the observations are less than or equal to what number?
No, because that'd be, if you use 24, that would be over half of the observations. Wouldn't it? Oh, no, okay, I see what you're meaning. I got it.
Okay, so the mean
Yeah, so that's
median is 24,
4.
so that's half of it. So wouldn't it be 24?
Yeah.
Yeah.
Okay.
Based on the information on the table, the top 25% of the students are above what number?
So I would say 27, right?
Yeah.
Yeah, that's.
Okay.
Hold on. The top 25%.
Would be the third.
Which is 75%, which is Q3, right?
Yeah.
Okay. My brain's going backwards. Sorry. Following statements is not one of the 3 rules of probability. The probability that kind of. Okay, the sum of the probabilities is, okay, the probability is high, then the probability is, okay, and the last one.
Yeah.
Well, I think they might be different, because mine is the second one. If the probability is high, then the probability is positive.
The one that has the word negative in it is not the one. The one that says if the probability is low, then the probability is negative. Okay, here's my question, you guys. I just went over like the homework, or not the homework, the preparation that we had to do. In the PX, like in that table we did, the PX was always a quarter.
Yeah, it's because
So it's 1 divided by however many X's there are, right?
Right.
So on this one, wouldn't it be 1, 2, 3, 4, 5, 6, 1/6?
On which number are you talking about?
Number 8.
Number 8.
Oh, okay. So the reason why it's not is because all of these are percentages. So the math's already done for you. If it was, you have 22 brown M&Ms, 13 yellow M&Ms, and like so on and so forth. Then you would do. Then you would divide that by the total of all the M&Ms, so that way you could get the decimal. Because you can't. So like, let's pretend brown M&Ms is 13, and let's say there's a total of. I don't know, like 24. So you do 13 divided by 24. And so that way you could get a decimal or a percentage. Yeah. And so my calculator says that it would be 54%, or 0.45. So the proportions are out of 100 M&Ms, basically. I mean, like, another way to think about it. But so we don't really know how many M&Ms there were total, but we do have the percentages.
The question that I have is, looking back in the homework, because it shows the 2 different tables. One where it uses the count that you get in the survey, and then like the true proportion. They use true proportion and estimated proportion. So when they're asking us for the proportion, which one are they asking us for? Like when they say what's the probability of drawing a red colored candy, are they asking for the
true proportion or the...
or the estimated? Because the true proportion, you'd be correct in that it'd be 1 divided by 6.
So it'd be that 0.1667.
Yeah.
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 If it's the estimated proportion, then it'd be what they gave us. But I just don't know which one.
Excuse me.
I mean, I could turn mine in.
Who's the martyr this time?
It doesn't matter to me.
Well, but see, then when you go on to 9, the probability of random selected candy is green, you've got that 0.16, which is, you know, because it talked about how it being close to that point, the true value to the estimated value, and that's going to be close to that 0.1667. But if you round to 2 decimal places, then you're looking at the 0.17.
Yeah.
I'm going to go back there. What portion seasonal 01?
Okay, so I got 100, so we're correct.
Yeah.
Oh, yeah.
Okay. So it is
Okay.
the true.
Well, so what did you put on number 7?
Number 7?
That it provides strong evidence?
Yeah.
You did the strong evidence, and then you did the 0.13 for 8?
Yeah, 0.13 for 8, 0.16 for 9, 0.84 for 10.
And 0.84?
Okay.
Yeah.
So when
Okay.
they're asking for the true. Okay.
Okay, I guess I'll submit mine. Is everybody else going?
I didn't put zeros in front of mine. Should I put zeros? Catherine, did you put zeros in front of yours?
No.
Okay.
Okay, I submitted mine, and I got 100, and I put zeros
I got
in front of
100.
mine.
I didn't
Good
put
job,
zeros.
guys.
This is like stressful. I can't handle it. Ugh. Seriously, stressful.
Oh my gosh, guys. This was the best quiz ever.
I know.
It was stressful. What are you talking about?
Probability can be, like, honestly, probability kind of reminds me of a mosquito. Sometimes, you know? Sometimes it's really easy to just, like, smack, and other times, like, you can't find it, you know?
Oh my heck.
I thought that went a lot better, though, to do the part 2 of our homework instead of, because I know with me, because I was thinking about it when I was doing it, like, I had to write down all of the, like,
Yeah.
the whole, like, graph.
I had to make my own graph. Yeah.
Yeah.
Or my own chart.
By the time I figured out the standard deviation, and it worked, but I thought, oh, that works a lot better than us sitting here on the
Trying to
computer
figure it
trying to
out.
figure it out. And then just making sure we all got the right answers. So should we do that from now on then?
I think so.
Yep.
Okay. So we'll just do that for lesson 5 then?
Yeah.
Mm-hmm.
Okay.
Awesome.
Okay, guys. Oh, Catherine.
Yes.
Can I ask you real quick, how do you, because for my other class, I have to do Google Hangouts and I have to record it. How do you record it?
Okay. What you do is you go to your Google Hangout that's online, and you have to click Google Hangouts on air,
Mm-hmm.
and then you click Start Google Hangout, and you give it a title and everything, and then it'll like pop up. You'll click like live feed now, but it won't start right then. It'll then bring up a page, and it'll just have a little box there, and it'll have in the bottom left-hand corner it'll say Start Video, and you start it there, and then that's where you invite all your other group members, and then you click Invite, and it'll start it up. and then on the bottom, after it loads everything, in the bottom middle, it'll say Start Broadcast, and you have to click the Start Broadcast or it won't record it.
Okay.
So then after you click that, at the end, you click Stop Broadcast, and then you like exit out of the screen that it's just the video, and then on that first screen, it will have your video there for you. And it also will upload to your YouTube account automatically.
Okay.
So, and you have to make sure, like, if you haven't verified your YouTube account, you have to do that because it automatically uploads. So your YouTube account has to be verified by you.
Okay.
But that's just how.
I'll try it.
Okay, and if not, you can just let me know and I can try to like, talk you through it again.
Okay. Sounds good. Yeah, I have to do this again for another class. So.
Yeah.
All right. All this new technology. I'm too old.
I know.
True story.
That's how I feel too.
I mean, they didn't have cell phones when I was your guys' age, so.
We did. We had just gotten pagers.
Oh yeah, I had a pager in high school.
Yeah.
I could actually spell my name. It was like 17704. If you flip it upside down, it spelled Holly. Yes. Okay. All right, guys. Well, have a good one. I'll talk to you guys later.
Okay. See you Thursday.
Have a good day.
Bye.
Okay, bye, guys.